Hi, good afternoon, everyone. Just want to introduce myself, Zakira Mohammed, and my colleague, Christelle Sampson. We'll both be interchanging today, take you through our journey in terms of what we've done around big data. We've named our presentation Driving Enterprise Adoption, our tragedies, triumphs, and our next. So, we come from a company called Standard Bank South Africa. It's the largest bank in Africa. We have presence in 20 countries across Africa, 14.9 million retail customers, and we've been around for 155 years. In terms of our big data journey, we started in South Africa, which is right at the tip there, and we are expanding into Africa. Okay, so our journey started in 2016. We started off with a POC environment, which was basically used by data scientists to do exploration. Our first task was to get critical mass into our data lake. So we started ingesting a whole lot of data into the data lake. We've currently got over 1,000 daily feeds, mainly from mainframe, across all our different product lines into the data lake. We then set up multi-tenancy on the lake so that we could establish a data science workbench that could be used by all the different data scientists across Standard Bank. To give you an idea, just in Standard Bank alone, we have about 120 data scientists enabled on our platform. So we started onboarding them onto the data lake, and they basically had a sandbox environment to start prototyping data science models. And this was across all our different business lines, so finance, corporate investment banking. We have a customer intelligence team in our retail banking. We then defined a model productionization process. So we thought that was quite key because we wanted to have a standard way of productionizing all these data science models. We also established a data science guild. So the Data Science Guild is almost like a community of practice, which includes all the different data science teams across the bank. And Christelle will give you more detail on that. Our next task was to implement real-time streaming capability on the lake. We then set up our first data science model that we productionized, which was a real-time machine learning model using k-means clustering and random forest. We then made sure we put security policies around the data using Ranger. We integrated our data lake, all our data, metadata, into our enterprise metadata repository. In 2018, we decided to shift to a use case-driven prioritization in terms of what we implement on the environment. Some of the challenges we faced were, well, right at the beginning when we started, was security. I think it wasn't as easy then to get things like Kerberos working properly. We really struggled with that. We also struggled and still struggle with using open source connectors in a Kerberized environment. The other thing that's a challenge for us is there's every tool or every application out there suddenly have connectors to Hadoop. So SAS, SAP, Actimize, IBM. So we find that we're having to integrate all these connectors onto our platform. It's challenging because we know that upgrading could become very difficult. The other challenge we have is skills. So specifically in South Africa, I think we were late in terms of the journey on big data, but also we don't have as many skills available. So we've had to nurture those skills and actively drive the education of the people that we employed. Another challenge, a data lake versus Hadoop. So just because we're using Hadoop to build a data lake doesn't mean that it's fit for all types of use cases. So we find people wanting to archive small files in Hadoop, thinking that it's their archival strategy. So we've had to deal with those type of things. We've also gone from having no demand, so basically just getting the infrastructure ready, putting the security in place, ingesting a whole lot of data, to where we are today, which is complete oversubscription. So we now, just in this iteration, because we run in a scaled agile framework in terms of how we deploy, we have over 12 models that are sitting on our backlog to productionize. Okay, I'm going to hand over to Christelle.
Okay, right, so a little bit about our landscape and where it is that we've actually come from. As you can see on the far left, focusing on data ingestion, which Sakira mentioned around us wanting to get critical mass on the data lake. We focus naturally on batch predominantly because we have a lot of mainframe. And so we actually have a proprietary tool which we're using at this stage to actually land data onto Hadoop. Our strategy was to land both onto HDFS and Hive in ORC format to support performance. And then naturally we had non-frame sources and are currently really trying to leverage Spark to really solve for ingestion using that particular pattern. From a real-time perspective, we've made an investment in a change data capture tool to help us accelerate our journey around getting data onto the platform using that particular pattern. And then for online sources, which refer mostly to our mobile apps and other, we started leveraging NiFi and Kafka to land data onto the platform. In our context, because of the nature of what this platform is geared to from a strategic perspective, we had to focus quite specifically on our data science workbench, which you would have seen as part of our journey. And in that, we've enabled our Zeppelin, Jupyter, Python, Spark. And our challenge, which you will also see further down the line, is just managing various versions of all of these packages because everybody wants to have their own version, they're creating custom things, which does create some complexity. But what we also decided to do, because we realized at this point that governance was really, really key, and that was at the center of the data strategy for the enterprise, was to make sure that we actually were getting this metadata into our central data metadata repository. So you'll see that we leveraged Atlas, but connected that to our enterprise tool in order to actually get a view of what was happening and stitching together our technical and business metadata in that particular platform. From a data provisioning perspective, getting things out is really one of the key things, because running the model in itself is not good enough. You've got to get the results out to an application. We've been focusing on leveraging our API gateway to do that. And at this stage, we've actually just started to productionize models using that provisioning pattern. Monitoring is really critical for all of the models that we're running, and this is outside of just performance. You want to know when there's errors on this thing. So we quite early on realized that we had to leverage something else in order to actually track what was happening with the models that were operationalized in our context. And for that, we leverage Elastic, and that is across both Elasticsearch, Logstash, Kibana, in order to actually also visualize per model exactly how this thing is performing in a production sort of state. Zakira already made mention of connectors, and this seems to be increasing, with the risk really being that we've effectively got to say to everyone who wants to connect that, look, if you cannot keep up, we will move without you, because the primary case for this platform is data science. And so that's become quite a difficult thing to navigate, but more and more vendors who have proprietary technologies are starting to embrace the fact that the open source community and everyone else is moving. So we spoke a little bit about some of the governance components, and security was really key for us. We've got a Kerberized production cluster, and we've done quite a bit around those themes from administration all the way through to data protection at this stage. And so those pillars really just show what we intended to do. We wanted to be able to actually manage who can access what data based on what role they had. And so because we've got so many lines of business, we went about setting up groups in Active Directory that actually defined people like me and what that meant in terms of what data can I access. And so that's sort of filtered through, all the way through from administration and authentication and authorization, through the use of Embari, Ranger, Kerberos, LDAP, and then Centrify, which we are using below. Some of our African countries have opted not to use Centrify and are using SSSD. And then from a data perspective, data protection perspective, Ranger KMS and SSL in use. Okay. Right, so from a governance perspective and speaking to metadata, the strategy for us was quite clear. We'd made significant investment into a central repository, as I mentioned earlier on. And so really what we're doing is taking technical metadata using OpenIGC to actually get that data into our central metadata repository. And then from any other tools, also passing the lineage through to that very same repository. But it's not enough, because often what happens is people don't know actually what sits on your lake. So we realized that we had to take this a step forward in the absence of having the latest version of the actual repository or tool. We had to build a catalog. In effect, what we wanted business to do was to be able to go to exactly their area, by product if necessary, what data do I have, and I'll show you what that looks like in a bit. The reason for that was because we had an enterprise strategy around data ownership, which meant if you're an executive in a particular product line, you own that data, and if for whatever reason there was something wrong with that, you would have to face up. And I'll talk about the reporting in a little bit. Okay. Right. So this is what it in effect looks like. Our catalog basically tells us exactly how many sources how many files, etc. we've landed from the various sources, and it also tells us exactly what kind of history we have on that. So any user could go to the catalog, search for what it is that they're looking for, and it would tell them you've got this particular data from the 1st of January 2015 to current. And that's been particularly useful for our data scientists because they don't have to navigate through tons and tons and tons of files. They simply have to go to the catalog, and it gives them that view. It also tells them who the owner is, so that in the event that their actual policy doesn't actually allow for them to access that data, they can request it. Okay, right. So in terms of these various lines of business, it was necessary for us to set up a multiple tenant environment. So what we have is effectively, at the very bottom there you see managed queues, again, against the groups, which were against the roles from the various lines, and naturally the managed storage component. But we set up edge nodes for each of those very distinct lines where it made sense. And it was really based on scale. So it had to make sense. It couldn't be just because I was from finance. If we were 2 users and we had very little data give us edge nodes, it had to make sense. And in some cases, we've actually combined groups. But effectively, we set up edge nodes for those, and then also established our production workbench, as well as the edge nodes to actually productionize models, which you'll see in a bit. And then virtual machines, naturally, to actually set up sort of an SDLC process for each of those teams. So repos as well, established. We have an established repo, and we run an Anaconda environment, which really just helps us to manage each of the various tools we have on Workbench, as well as all of the respective packages that are required by each of the teams. Okay. So on that note, I'm going to hand back to Zakira just to talk about self-service and what that meant then on the edge node and what it means for how people then interact with that and what kind of roles and responsibilities are associated with that.
Okay. So basically, our data scientists who are playing around on the edge nodes, building their models, have what we call self-service. They can pull in data from anywhere onto the edge node. They can prototype models. They can use any of the tools on the data science workbench. They can build streaming pipelines into those models. And then there's a process to productionize. So self-service is on the edge node. When they want to productionize, there's a proper governance process in place around how we do that. Okay. Sorry about that. Okay, so in terms of the rest of the African regions in which we operate, we decided that, or actually we didn't decide this, but the African regions themselves, some of them are bigger in terms of size and in terms of volume of data. Some are tiny. So we have a different strategy for the different countries. For example, Nigeria, which is a much larger country, have a lot more volume of data, and they have some skills in the big data space, so they've set up their own big data cluster. For other countries, what we've recommended is that they basically use our cluster in South Africa to build their data science models. So we have a private cloud offering where they can basically do their model training of the data lake in South Africa, ingest their data, make the results of their models available to their systems via APIs, and that can accommodate batch or near real-time models, but not low latency. And that seems to be fine for them as a starting point to get the skills and start exploring in this space. Okay. What we've also figured out is that the world of data science and engineering may have some overlap, but it's pretty much quite different. In the data science space, I guess I'd say there's not many standards. There's a lot of tools, and the data scientists ask for all these tools. I mean, I actually remember us getting a list of like 36 tools across all our business units that they wanted enabled. We had to go through that with a fine-tooth comb and say, well, actually, like there's 6 of the same thing on this list. So in terms of the overlap, Hadoop is in there, some of the normal SQL databases, but there's a lot of distinction across the skills in the engineering and data science space. I actually saw another presentation, I think it was the MasterCard one, that described this quite nicely in terms of the roles, data science versus engineering, because engineering is also split into the operation side, as well as software engineering, as well as data engineering. So we had to figure out what the process would look like and who would play what part in productionizing models. So this is basically our model productionization process, defining the roles. You'll see the data scientist. They look at the business requirements. They look at the data they need sourced for their model. They build the model, test the model, optimize it. The data engineer plays a role in sourcing the data. The operations engineer plays a role in setting up all the correct folder structures, new ingestion pipelines, supporting any tool requirements, and then monitoring and launching the models into production is where all 3 roles kind of get involved. We've had a lot of debate around how this would work in our agile framework, because we have teams embedded in business that are proper feature teams. They have data scientists. They don't have engineers, funny thing, because everyone's hired data scientists and no one's thought about how they're going to productionize models yet. So we're now on a drive to look at building the skills in the engineering side so that we can support the data science functions. And yeah, so this speaks to that exact problem. So we found we had a whole lot of data scientists, very few engineers, and we actually had to educate business in terms of what these different roles are and why we need them and why they're complementary. And I guess the ratio, I don't know what the right ratio is, but it would depend on a number of things in terms of complexity, sources, variety of data types, technical skill required, complexity of the use case. So all of those would play a role. The Data Science Guild. Okay, so we also have a Data Science Guild with a mandate to basically bring together all the different data scientists across the group. The Data Science Guild establishes the standards around data science, looks at skills, and they've basically split up into different working groups. The one working group looks at tooling, so if someone's asking for new tools, it goes into that working group, they evaluate that, and decide whether we would be adopting that. So then we whitelist that tool, make it available on the workbench. Model productionization is another topic. So I suppose this goes across the different types of models. How would we productionize a model in Spark, in R, and it could be slightly different. Governance as well, being a key topic in terms of just data governance and also governance around the model. So someone's built a model, how do we know that that model's sound? And that's something that we starting to focus on now to make sure we can establish some standards around actually being able to evaluate that. And the other thing is training and development in the data science space. In terms of deploying models into production, initially we started off with option 1, which looked at building the model, training it, and just productionizing it on our lake. Where we're moving to now, and I'm saying now as in this iteration PI 2 of this year, we're looking to move to option 2, where we actually deploy the model predict onto a deployment server in a containerized environment, and that's really to ensure that we have scalability in terms of running these models in production. Okay, model serialization, also just something we're grappling with now in terms of how would we serialize different types of models. I won't go into too much detail there. I'll hand over to Christelle. She'll take you through some of our AI use cases in terms of what we've been up to till now.
Thank you. So the use cases all sound very simple until you realize that you actually have to establish an entire solution design for each and every single one. You start off and you think that, well, if I've done one, I can do any. But the reality is that you have to consider for each tool you're using, whether it's language, etc., there's going to be variation. And in that, there would have to be some kind of decisioning around how you would actually support that from a design perspective to make sure that this thing was really industrial strength, because that's in effect where you would want to get to ensure that you've got stuff running that's sustainable. But we focus predominantly on AI, and to give you an example of some of the cases that we have, while they sound simple, quite different in the nature of how they've been set up, really focus on us changing the way we react to trading environments in one example, and the context there really speaks to global markets. Early detection around whether a small to medium enterprise is really starting to be impacted by what's happening in industry has been a focal point. And some of these things people don't know are coming necessarily unless you're actually seeing what's happening out there in the news, tracking that, starting to alert someone and being really good about actually getting to the customer early before it's happened and starting to look at ways you might want to differently look at the deal and potentially restructure some things. One size fits all really speaks to anomaly detection. We actually see this as solving for many domains, and I think many of the cases that we've seen throughout this conference really speak quite predominantly to anomaly detection in many cases. One which particularly stands out in our context because we are a bank, fraud detection. So that one is a particular standout. Who are you? That's become something that we focus on from a security perspective. And so in this context, our security team are in effect sponsoring a facial recognition engine to enhance security for digital channels. So everybody's moving over to iPhone X. We're really looking at how we can actually leverage facial recognition as a tool for authenticating who the customer is. And then beyond that, some of the others that we're working on is connections, which is really important on a continent like Africa. So apart from knowing who is connected in a particular geography, let's say just South Africa, you've got the same customer who's running a business in Kenya, who has interest in Uganda, who's doing something in Ghana, and who possibly resides in SA and is running his personal banking out of there, yeah? And you want to know what those relationships are between the individuals and the entities, but also where those entities and individuals are also related with other things. And the way to do that is to, in effect, really leverage graph capability in our context to actually look for ways to generate new leads, because we know that they're making payments to other people. We know they're receiving payments from other people. And so these are some of the cases that we're starting to look at. We've got a very unique context in South Africa, and for those of you who are familiar with our history, we have 11 official languages. To make that more complicated, we use shared terms or phrases to actually to display or show some kind of emotion. And these phrases are popular, so you'll see them up there and not know what they are. But as an example, shap means like cool, awesome, yeah? Eish, like what the hell, right? But these are all things that we actually generally don't get to be able to analyze out of normal sort of sentiment analysis, and so we're having to do something different around that, and natural language processing is helping us in the techniques to actually really sort of understand what's happening when people are actually posting things about what's happening on the service channels, etc., because they use phrases like that. Show your money who's boss. Financial management, we've all seen the tools. There's a bunch of things out there. They cost a fortune. And quite frankly, their accuracy sucks. No one knows your narratives like you do. No one knows the context like you do. And so we've been looking at how we can actually take data from transactions and start forecasting what a customer is going to be spending on next. In our context, debit orders or scheduled payments are a real good forecast to understand what's happening in our customer's context. And that also includes things like money coming in. We can now start forecasting ahead of that and start making offers on that basis because they start to trigger certain events. So that's one that we're working on at the moment. And then we've got work smarter, not harder. Intelligent automation and robotics are becoming a reality in the context of financial services and many other industries. What we are doing is leveraging a lot of the models that we develop in the other contexts to actually help support embedded artificial cognition, and not leveraging or buying into a whole other platform, but rather integrating to this big data platform and passing the results out to the other technologies. So that's just a quick overview around what it is that we are covering there. Oh, it does not respond. There we go. Right, so as an example of connections and establishing those between customers, we leveraged Graph to do this, and we wanted to solve for quite a different problem. So we've got a lot of legacy. If you think about any platform or tool ever known to man, any database, we've got them. And a lot of them are with us and are being replaced, but slowly because it's quite a big business. And so what we had was a particular problem around being able to actually link what's happening, the profiles on our mobile apps to a customer, because there was another identifier because of all the legacy we have. And so it became very difficult to actually see a link between Christelle, her cards, the accounts, and where secondary accounts are held, secondary cards are held, the relationships between other individuals, possibly any entities, again, using my example from before. And really what we needed to be able to do is to have a very clear view of that, especially in the context of where we were finding high levels of fraud because of the creation of fake IDs on the actual mobile channels. So what we decided to do was leverage Graph. In our case, we tried quite a few solutions early on. There was the Titan DB foray, and then we tried a little bit of Janus Graph. And at this stage, we've been leveraging Neo4j. And effectively, when you start out, that's what it looks like. You have an establishment of links between specific things, and you can see those nodes through. But what we wanted to be able to do was take this a level up, because somebody in the business doesn't necessarily understand what that big schematic sort of view actually denotes or illustrates. And so what we did was take that, be able to show them exactly what links there were between the actual digital ID, which is christellesampson@gmail.com, against which cards, against which account numbers, which are depicted by those color-coded nodes over there, to actually see what kind of connections there were. And you can scroll over those. For those of you who are not familiar with Graph, you could actually scroll over those sort of dots, and they would actually tell you exactly what the detail behind each of those are. So you can see that this particular guy with digital ID, Glenn Allen, has several account numbers, and that's all linked to one card. And you could actually see what those accounts were. We needed to visualize that in a way that made sense. And so one of the data scientists who started out on a prototype actually created some kind of hierarchy to show what that might look like. This is really easy and simple for someone to use when they're in a case or investigating it, but we've since naturally evolved as well. And so there's a lot of machine learning that's supporting some cases around actually pushing out flags. And so at this stage, we're looking at actually automating processes around soft blocking any cards in the event there is actual anomalous behavior. So that's just an idea of where we've been. In terms of our next, so our logo at the Standard Bank of South Africa is we ask our customer, what's your next? Our next, in terms of where we're going, really speaks to how we're going to productionize models given all of this variance, because there is preference for certain tooling. The framework still, however, has to hold, and the principles have to hold fast. And so we've started with Python Spark models and are focusing on how we actually ensure that we actually are able to take that through the pipeline, as Zakira would have shown earlier on around roles and responsibilities, but also, again, making sure that you can monitor them, etc., as we've spoken about before. And then we'll be looking at R, TensorFlow, and Graph. In terms of our next, so the focus really is on establishing a microservice architecture. That's better, okay. Around establishing a microservices architecture to really support the provisioning of data out of our platform to other applications, etc. And then self-service to enable business units to really help start supporting not only just themselves from a data science perspective, but also to start helping us on the ingest of the data, because that really is what then becomes the thing that keeps you back. If we don't have data from authoritative source, that sets us back from a productionization perspective. And so we're looking at that at the moment, really leveraging Spark to enable quite a lot of that. Data tokenization is on our roadmap. Anyone in financial services will know. Card numbers, otherwise known as PANs. Identity numbers, or in your case, social security numbers, etc. We've got so many regulations that speak to those specific sort of attributes that are just really problematic to control in an environment where you've got thousands and thousands of users without being able to actually zone in on that without the use of a tool that is adequate to support you on that journey. And so we'll be looking at that in this year. We've POC'd a few options. And as for many of you, naturally cloud. So we've been on a solely on-premise journey, as Zakira mentioned, and supporting the rest of our African countries with a private cloud, but at this stage are starting to look at cloud as a means for the enterprise really overall to start leveraging this capability and reducing naturally all the overhead that comes with managing massive data centers. And so that's really where we're going on our journey. And we are really incredibly grateful that you came out to hear us out, and would like to invite you to ask any questions of us. There is a microphone in the center of the room here, which we are encouraged to use so that your questions can be recorded and we can respond accordingly. Thank you. Could I ask you to use the microphone? Sorry, so it's just that we'd like to get the feedback. Thanks.
Did you enlist the help of outside help, or did you do all this by yourself, like internally?
That's a very good question. So at this point, we give a shout out to Hortonworks. We run a Hortonworks distribution, and we've been working very closely with a data scientist there who has been instrumental in taking the Python journey forward, and he came with a lot of insight. We ran an engagement that spanned a quarter, and in that quarter we managed to actually put together a solid framework for Python Spark models, and are now using that as a blueprint in which we can actually start replicating that in some parts for R models, TensorFlow, etc. So we did enlist help.
And Chriselle?
But we actually executed. We took advice and guidance from the
And we also got DevOps specialists currently helping us set up our CI/CD pipeline for model productionization, also using consulting services.
Okay. My question will be, can you give us some example about the data acquisition challenges for the application you're using? And also on the another side will be the analytical, the guild, because I do see you have a mixed communities who are Python user, R user. How do you plan to really into the production in terms of analytics in the future?
Okay, I didn't get too much of that, but I'm gathering that your question is around how we act. Two questions.
Yeah.
One
First
was
thing is about, can you give us some challenges for data acquisition
right
side?
challenges. Yeah.
Second side is on the analytical side.
Yeah.
You have a large amount of data scientists in your organizations. There are Pythons, there are Rs, there's SAS, there's all kinds of flavors.
Yeah.
Then what's your plan to, become a production so people can leverage more with different contributors for different platforms?
Okay, so the first one around data acquisition, we were very, I guess, lucky because we had a very clear data strategy. The enterprise had put together an entire enterprise information management architecture, which really spanned everything from source all the way through to literally how do I get a dashboard or something visualized out and getting a result into another application, etc. And in that, that spanned also patterns for how we would actually land data as a standard across all of our platforms. So our architecture, we do not intend to replace a warehouse with this. We've kept Teradata. We do not intend for people to come to this platform to do a lot of ad hoc query, and also we're not expecting to have a high volume of users running those queries for operational reporting or anything else. We have what we refer to as our reservoir for that and are running an appliance, a SQL appliance to do that. So it was very clear around how we were going to use our platforms, but the patterns were also very standard and defined. And there is no tight coupling between any of these, which means that those patterns feed to all as a standard, and that helped us to keep this framework pretty clean. We also made very clear decisions early on to stick to certain tools and not to expand that too wide, because the mistake that we often make is, oh, but this one looks prettier, and so I'll just get that as well. And oh, this one, it's easier to kind of like manage through this really cool console, so we'll get that. We had to take some firm decisions up front. In terms of analytics,
on the analytics side, I just want to come in on that one. So we have SaaS. We have a huge community of SaaS users. We are evaluating running SaaS grid on Hadoop. And where we've gotten to for now is we've done performance benchmarking around taking some of the queries and running them on Hadoop and actually seeing what runs best on Hadoop. Our conclusion is if you're running proper analytical models, the performance is better on Hadoop, but a lot of people are using SAS for BI, and we want to move them to the appropriate platforms like the warehouse. So that would be our strategy.
Okay. In terms of making sure that there was adequate skill then, we're also running, together with Hortonworks, boot camps on site where the various guilds have representation, so data engineering, data science, very specific training on Hive, etc.
So being a fellow financial services person, one of the big issues, as you probably know, is around data privacy problems. So given that you have regional presence, like how did you roll out the strategy to enable all of this while keeping in mind likely restrictions on data movement?
So in this context, I'm guessing you're referring to regulation and how that differs between all of these other entities, yeah. Okay, so we do know that there are some countries where the rule is the data originated here, stays here, and is utilized here. You never ever ship that out. And so for that reason, those countries would deploy their own instances. We have several of those, although it's not predominant, particularly in some of the regions. So what we are doing in that context is where it is not a specific requirement to support them in their data science journey by allowing them to connect to the SA instance. It's the same AD Forest, so it's all slick. And everybody else is really effectively going on the exploration journey within that environment. We're allowing them to ingest data, and in fact we have a whole bunch of that data on our backlog as at today. And that's effectively how we are supporting them until such a time as either the regulations change or we find a way to get around it. That will be the case.
I want to ask and open up the question around challenges a bit more beyond data acquisition. Mm-hmm. Were there any implementation challenges or surprising shortfalls you found along the way?
Yes.
Plenty.
So the first thing we realized was that actually when a data scientist is done building the model, it's a prototype. We weren't expecting that. I don't know why. So that's where we're at. And what we realized is that there's actually significant engineering effort to properly optimize the code and productionize that. So that's one of the challenges we faced with now, because we realized those 12 models we need to productionize. We probably going to have to rewrite all of them.
There were others. So you would have seen one of our successes was security. One of our biggest challenges was security. So what we really struggled with was, because everything was Kerberized, the second we wanted to use connectors, etc., that became a huge challenge for us. And we've actually spent a significant amount of time rewriting some of those to actually get them to work, because they simply didn't work out of the box. And so that's something that's been a particular challenge for us. But I suppose it sets the pace, because also part of our strategy is to effectively Kerberize everything in our entire ecosystem. And so everyone will have to join on that journey at some point.
Hey, I have two questions. First one, can you put some more light on CDC part when you bring in the data?
Okay, so we're looking at pulling in a lot of our SAP data, mainframe data, using the CDC pattern. That picture wasn't entirely correct. So from CDC to Kafka is how it would go, in case you were wondering. So that was a mistake on our slide. What else did you want to know around CDC? And the whole reason around that is want to move away from batch and into a more real-time provisioning pattern to support more types of use cases.
The second one, you said like your main data warehousing platform is in Teradata. So I believe it is in FSLDM. So do you have any design patterns, like subject area design patterns inside the data lake, like tagging parties, transactions, accounts, something like that?
So no, our principle around loading data in the lake is we just load it exactly as it is in source. We haven't created any kind of schema on top of that. So it's exactly as it comes in from the source system. We are looking at, though, for where the data is used in a data science model. I don't know if you saw that picture around our central metadata repository. In there, we would have all these domain entities defined around party, etc., which would link back to the technical metadata, which sits in the lake.
But there's also a question about then also creating curated views for where something is reused time and time again, which is part of our journey as well.
Okay,
yeah.
So curated views, that's something that we realize that even in the data science context, you know, people understand the data well. They may want to save others the effort of having to understand raw data. The problem we have is a legacy problem. So our warehouse, we don't have lineage and all of that properly defined. So we have data scientists, and this is a challenge, wanting to use the data to build models. They don't understand what rules were applied to the data. So we're trying to force them to use the raw source data and build up those curated views properly through a proper governed process over time. As opposed to going to the warehouse, the current existing warehouse, and building models off of that.
Yeah. And unfortunately, that will have to be our final question, because the lady's been flashing that time's up several times.
So approximately how many users use the tools that the data scientists produce, and then how many people support that whole
Good question.
platform?
So we mentioned that we had approximately 120 data scientists. In total, we actually have 158 users as at today. The remainder of those 120 being those who support it. So it's quite significant. It's large. Most of them being focused around administration/operations because of the kind of demand we have from a tooling perspective. And then we've got, sorry?
Ingestion.
Oh, yeah. Then we've got an entire team focused on engineering and governance, which really speaks to ingestion and all the frameworks and the patterns around that. And then we have a whole other team who just focuses on bringing in data from a particular source so that we can close out the critical sort of mass question around that. So the ops team, we currently have 3 in our team, but we have vacancies. So you would have seen my note on the grey board in the in the expo center.
Yeah, and we have about 25 developers, data engineers. And we realize that we have a huge gap in the software engineering space, which we're also recruiting for.
Okay, thank you very much, everybody, for attending. We hope that was helpful. Enjoy the rest of the summit.